So in this video, I'm going to finish up the lesson we started today on 3.0 power, constant, sum, and difference, and transcendental derivatives. So here we are. Here's the example. It says values for a differentiable function f and its derivative are given in the table for x equals 2. It tells us what a of x is and tells us what b of x is. Find the equation of the line tangent to y equals a of x at x equals 2. Well, we know that is going to be y minus y1 equals mx minus x1. So first of all, we know what x is, so we got to find out what y is. So here's the equation for that right here. So we have a of 2 is going to be 2 over 2 plus f of 2. 1 plus f of 2 is over here in this table. Oh, 1 plus negative 3 is a negative 2. Perfect. So now we have to find the slope. Okay. So we're going to rewrite a of x as 2x to the negative 1 plus f of x. So when we take a derivative, we get negative 2x to the negative 2 plus f prime of x, which is negative 2 over x squared. All right, so we want to find what the value of the slope is. So basically that is going to be, I'm going to go like this. Slope of the tangent line when x is equal to 2 is going to be negative 2 over 2 squared plus f prime of 2. So negative 2 over 4, that's a negative 1/2. And f prime of 2 is 1, which is 1/2. Okay, so we're ready for our equation of the line. I'm going to scroll down a little bit. I'm going to take my little eraser and I'm going to go like this. Okay, so here we go. Y minus y1, which we found to be negative 2. M is 1/2. There's the equation of the tangent line. Part B. All right, we know y equals b of x. So up here, let's find x is 2, so let's find the y value. F of 2, looking at the table, is negative 3. It's negative 8. All right, and now we're going to find the derivative. Using this information up here. F prime of 2 is 1. Minus 1 is 1. So here we go. Equation of the line is going to be y minus y1, which is 8, Okay. So we have more derivatives. So the derivative of sine of x is cosine of x. The derivative of cosine x is negative sine of x, and the derivative of e to the x is e to the x, and the derivative of natural log of x is 1 over x. These four functions are the four most common transcendental functions that you will encounter through AP Calculus. If you plugged the function sine of x into Desmos and took the derivative of that, you would see the graph of cosine x and so forth. And you can experiment with that in Desmos. Find the derivative of each of the following. Okay, so f prime of x, 5e to the x. G prime of x, derivative of e to the x is e to the x. And h prime of x, 7e to the x plus, oops, m part d, 3 over x plus. All right. So this first AP question I'd like to talk about with you. What is the value of the limit as h approaches 0 of 16 plus h to the 1/4 minus 2 over h? We want to recognize that that is the definition of a derivative. So we have to think about x and f of x. So we know that f of x is 2. And so we're trying to think about right here, 16 to what power gives us 2? And it's 1/4. So therefore, that tells us that the function that we're dealing with here is x to the 1/4. If we take a derivative of that, it's going to be 1/4 x and if we're trying to find f prime of 16, so the 4th root of 16 is 2, and 2 to the 3rd. Is 1 over 32. Now, I want to kind of talk about this AP question right now. We're given a piecewise function. If g is a function defined above, then what is g prime of 1? So first we have to prove that it's continuous. So the limit as x approaches 1 from the left. And the limit as x approaches 1 from the right. So the limit does exist, the value of the function exists, and the limit equals the value of the function, so it's definitely continuous. So now we can work on getting a derivative. So the derivative up right here is -2. And up here, the derivative is 5. And in order for a derivative to exist, these need to be the same. So therefore, in this problem, it's asking for g prime of 1. G prime of 1 does not exist. So there are other AP questions that you should go through and work through and check your answers in Schoology with the posted notes.